worksheets yesterday. We had to ask Mrs. Marshall about some of them because they had two variables in them.
But they were actually really easy.
Yeah. Once we figured it
Oh,
out.
did I not go over an example with two variables?
No.
Oh. I thought I had done one in the notes. That's why I gave you those ones. Oops.
It wasn't too hard though, because they were like different squares.
Yeah. Well, you still have to. You still treat them the same way. It's just they're not going to typically give you. Yeah, they're only going to give you two variables if it is a special type. They're not going to give you two variables in.
Oh gosh. There's like 5 people sneeze out there.
Something in the air, apparently. All right, so 4.5, solve quadratic equations by finding square roots. So basically, this section is mostly just breaking down square roots as simple as possible. So, starting with number 4, square root of 192. All right, so it's not a perfect one, so we need to break it down. So we're going to factor it. So 192, well, I know 2 is going to come out, and 96.
Okay,
I'm going to...
We go into 96, I think.
Yeah, I think it can. I'm going to, well, I would recommend you go as simple as possible.
Okay,
So
we do 2 or 3.
Yeah, 2 or 3 and something. Let's do 3 just to 32, right?
Yeah, 3 is good because you can do it in the 9.
Easy.
And then 32,
84.
8 and 4. 8 is 2 and 4. And then 4 is 2 and 2. 2 and 2. So then to pull something out, there has to be 2 of them. So we're going to group 2 2s, 2 2s, 2 2s, and then there's going to be a 3 left over. So we're taking out, okay, remember, there have to be 2 of them to pull it out, but because you're taking the square root, you're only going to write one of them. So it's going to be 2 times 2 times 2, and then times the square root of 3. So this simplified would be 8 root 3.
Easy. I love how easy this is. Is this
Yeah,
as
it's
hard
not.
as it gets? Really?
There's a little bit harder stuff in this section. It's not bad, it's just a little bit harder.
I remember this from all the I was terrible at our 9th grade, but
We did this, but we didn't do factoring. Did we do factoring at all?
A little bit, but I think it was over quarantine.
Yeah, it was. I think that based on where that chapter is, you probably were quarantined for most of this stuff. All right, square root of 3 times the square root of 27. So if you're multiplying square roots, you can multiply the stuff that's inside of them. Okay? If you're adding or subtracting, you can't. Okay? Right now, obviously, we're just multiplying, but just like FYI, if you're adding and subtracting, you cannot just combine what's inside. Okay? They have to be, you have to treat a square root as like a like term when you're adding and subtracting. They have to be like the same thing in them. So like the square root of 2 plus the square root of 2 would be 2 square root of 2. Okay? So
It's like
anyway.
fraction.
Yeah, basically. Alright, so this one, square root of 3 times the square root of 27. We can rewrite this as the square root of 3 times 27. Okay, and I'm ultimately going to try to pull stuff out, so I'm not even going to actually multiply it. I'm just going to leave it like that. So it's going to be broken down into 3 and 27. 27 is 3 and 9. Then 9 is 3 and 3. So then grouping stuff, I've got 2 sets of 3s. 2 sets of 2 3s. So then I can take both of those out. So 3 times 3, which is 9. Okay, you don't necessarily have to write all this like 3 times 3. Like, you can just see it over here and just write the answer. I'm just doing it so that
So,
make sure we can see it.
does that mean like 3 times 27 multiplied it would be a perfect square? Because it's just
Yeah, because if, well, and that was the thing, if you had done it that way instead of like factoring it out. 3 times 27 is 81, so the square root of 81 is 9. So, I mean, sometimes it might be worth it to do that, to check it, but I'm just trying to demonstrate the process so that you have examples to look at. But yes, you could have just said, oh, well, that would be the square root of 81, which is 9. 8's a little different, so let's do that one. 5 square root of 24 times 3 square root of 10. So with one like this, what we're going to do is we're going to multiply this, because again, multiplying, they don't have to be the same. Okay, so we're going to multiply the stuff that's outside together. So we're going to have 5 times 3. So we're going to have 15 times, and then what's inside the square roots are going to be multiplied by each other. So it's going to be 24 times 10. Okay, or 240. But I'm going to go ahead and leave it separated so that I can break it down. So 24 and 10. 24 can be broken into what? Okay, 10 can be broken into 2 and 5. He was like, 2 and 5, and I was like, 24?
I said I was like 2 and 5. Oh, wait.
He was so confident about it. This was funny.
6 and 4.
6 and 4. And 2 and 3 and 2 and 2. So I've got a set of 2's, another set of 2's, and then I have a 3 and a 5 left over, so I can pull out 2 2's, so 15 times 2 times 2, and then the square root of 3 times 5, so 15, so 60, square root of 15.
Yeah, it is.
It is.
I always mess it up though when I multiply 50 by something because
It's just 15.
when I count one.
What?
No, 15 will be up sometimes.
When I count wrong.
All right, 10. We have the square root of 35 over 36. Okay, so that fraction is all underneath the radical.
That's fine.
Okay, so since it's all underneath, what we can do, okay, there's a rule that says we're allowed to do this. We can actually separate this into 2 separate radicals, a top and a bottom. So the square root of 35 over the square root of 36. Now, what do you know to be true about the square root of 36?
It's a square root. Perfect square.
Which is what?
6.
6, and then on top I've got 35, which breaks into 7 and 5, which are prime, so you can't do anything else with them, so you just leave the top as the square root of 35. Okay, the only rule is you cannot leave a square root in the denominator. Okay, which we're going to do a problem like that here in just a second.
So they wouldn't make it so the bottom is, it can't be.
Oh, no, they will. That's what I'm going to show you what to do to get rid of it. You can never leave a radical in the denominator. Always have to move it. Okay. All right, so number 12, 7 over the square root of 12.
Oh.
All right, so the 7, obviously, just chilling on top. Okay, 12 can be broken down. 2 and 6, and then 2 and 3. So I can take a 2 out of the radical and then be left with a 3. So it'll be 2 root 3 on the bottom. But that's not allowed because I still have a square root on the bottom. So I am going to rationalize it by multiplying by the square root of 3 over the square root of 3. Okay? It's the same thing as multiplying by 1, which is why I'm allowed to do it. So, on the top, I'm left with 7 times the square root of 3.
So it's fine on the top.
Yeah, so the top is completely fine. Somebody out there is sound like they're dying. That happened to me while one of the classes was taking an exam. I Mr. Fletcher made these like cinnamon sugar pecans.
Oh.
And I was eating them, and like some of the cinnamon dust like went down my throat, and I literally just kept coughing. And they were like, "Are you dying?" And I was like, "I'll be right back." We just had to leave because it would have been like super obnoxious. Because I couldn't like drinking water didn't help. I literally just needed to like cough it out, and I was like, oh, it was so bad. Anyways, random side note, but. All right, so when you multiply a square root times a square root, okay, remember you multiply what's inside, so that really is giving you the square root of 9, which is what? 3. So 2 times 3 is 6. Okay, the other way to think about it is you have two things that are the same, so you can just pull it out. Okay, radical just goes away. So no, not hard, just different. Alright, I'm going to have you guys try one really quick on your own, and then we'll go over it. 14, the square root of 13 over 28. Okay, so all of that's underneath the radical. It's the last one of this type that we'll do, so take a minute and do that.
I was thinking we just resort to the same thing.
Do you have Decepticon?
I don't think so.
I hope you don't.
I have not done this since I've been in school. I literally played all 4 quarters and I didn't get through. I was so tired.
Did you hit anybody?
No, we played man the whole time.
Last night?
Yeah. I was like, last 4 minutes of the 4th quarter, I was like, oh crap.
That's great.
Yeah. My legs are bleeding.
Alright, how did we do?
Got it. I almost tried to break down 91 again, and I was like, wait, it can't, like,
13 and 7 are prime.
It can't do that.
I know, well, when I was trying to figure out about multiplying it, I was like, well,
Me too.
13 and 7. I was like, well, when you multiply that, it might break down into something. And then I was like, wait,
No.
13 and 7 are prime. That's not possible.
Well, I was like, maybe there's something else. Break it down. But otherwise,
Yeah, no.
Yeah.
Nah.
don't worry.
All right, so I've told you that you can't leave a radical on the bottom. So I've showed you what to do if that's the only thing on the bottom.
Don't.
But if we're adding or subtracting on the bottom, just multiplying the top and bottom by whatever's in the radical isn't going to fix the problem because you'd end up distributing on the bottom and you'd still be left with a radical. So I'm going to teach you how to get rid of it. Still not hard, just a process, okay? So 16, we've got 1 over 5 plus the square root of 6. Okay, so we're going to start out simple. So if I just multiply the top and bottom by the square root of 6, then on the bottom I'd end up with 5 square root of 6 plus 6.
Oh.
So I would just keep going back and forth. So we're going to use what we call a conjugate pair, okay? And we're going to actually multiply it by 5 minus the square root of 6. What you're going to notice is that when we do that, you're going to have a difference of squares, meaning that middle term that would end up with the radicals left on it are going to be gone, okay? So what I'm doing is I'm multiplying the whole thing by 5 minus the square root of 6, okay? And if this sign was negative, let's say we started with 5 minus the square root of 6, then we would have multiplied by 5 plus the square root of 6, okay? You're trying to set up a difference of squares, okay? So on top, in this case, since it's just a 1, we can just copy it over, 5 minus the square root of 6. On the bottom, I have a difference of squares, so when I multiply that, I'm going to get 5 squared, which is 25, and then minus the square root of 6 times the square root of 6 is going to be minus 6. Okay, remember, we would have the minus 5 root 6 plus 5 root 6 term that's canceling. Okay, that's what makes it a difference of squares. So then our final answer, 5 minus the square root of 6 over 19.
So you just leave the top.
Yeah, so the top, it's fine, but the bottom, you got to get rid of it. All right, get one that's a little bit harder. 18. 3 plus the square root of 7 over 2 minus the square root of 10. So this one has a minus sign in the bottom, so when I multiply it, I'm going to be multiplying it by 2 plus the square root of 10. Okay, the top isn't relevant for anything other than it's just sitting there looking pretty. Okay, so the top, I'm just foiling. So 3 times 2 is going to give me 6. 3 times the square root of 10, 3 root 10. Square root of 7 times 2 plus 2 root 7. And then square root of 7 times the square root of 10. Again, because we're multiplying, you can combine that, so it's going to be plus the square root of 70. All over the bottom, we've got a difference of squares, so 2 times 2 is 4. Minus square root of 10 times the square root of 10 is going to be just 10. And then I'll just simplify it as much as possible. Okay, sometimes it'll work out nicely where something up here will like cancel out, or the square root of 70, okay, it can't be broken down because you just have 7 and 10, 10's 2 and 5, so nothing's going to break out of it. If you can take something out, you need to do so. So I'm just going to keep the top as is. And then on the bottom, I'm just going to have negative 6.
I don't know why, but it feels so wrong. I know you didn't do anything, but to leave the top like that,
I know. It just
feel
doesn't
right.
look, it's not satisfying to leave it.
Satisfying at all.
And I just want to make sure that just because I've seen it happen, I want to make sure that you know that you can't do this.
Isn't there peanut?
That doesn't make sense.
Because it's not being multiplied. If that 6 was being multiplied by everything, sure, I could absolutely do that. But it's not. It's just being added, so I can't do that. Okay. I point this out because it happens frequently. Maybe y'all
Seems like something.
maybe y'all won't do it, but it happens a lot. People will be like, "Oh, simplify." And I'm like, "Nope, can't do that." Doesn't work that
We
way.
do this here.
Um
That's not bad. Watch me,
Alright.
I'll probably do it.
I mean, okay, like I can't say I've never done it, but like that's why I'm telling you, it happens a lot more than you would think. Like a lot. All right. So then the next one say to solve the equation, okay? I'm going to say this over and over again. Plus or minus you're solving an equation and you're taking a square root, the answer is always plus or minus because it could be either. Okay, because it's something squared. And we don't know, it could be either positive or it could be negative. So, I'm going to say that over and over again. Positive or negative, plus or minus, plus or minus, plus or minus. Because you will forget the sign and it's not right if you don't have those signs with it. Okay. 22. So, we have s squared is equal to 169. Okay, so the difference is if I just tell you to take the square root of 169, you would tell me the answer is what? 13. But because it's a s squared is equal to 169, there's two possible answers because I'm finding s. S could be positive or s could be negative. Okay, so when I'm taking the square root of both sides, s is equal to plus or minus, hello, what is wrong? What is going on? There we go. Plus or minus 13. If you leave it that way, that's okay. If you go on and you decide that you're going to go the majoring in math route, your professor's going to yell at you for leaving your answer that way because it cannot be both positive and negative at the same time. So, the correct way to write it is s is equal to 13 or s is equal to negative 13 because it can't be both at the same time. If you leave it here, you're not in a class where you're majoring in math. The first year I really cared about it, and then I realized, why am I caring so much? Most of these people probably aren't majoring in math. Okay? So either of those ways to write your answer, so you can have this or you can have this. Okay? But you have to have the plus or minus listed. Okay? If you just give me the plus, you're not going to get full credit. Okay? If you just give me the minus one, you're not going to get full credit. You got to give me both. Let's see. Papers are sticking. 28. 7r squared minus 10 is equal to 25. All right, so I want to get basically r by itself. So what do I need to do to get r by itself?
Add 10 to both sides.
Add 10, so that's going to give me 35.
And then divide 7.
Divide by 7, so what does that give me?
5.
5. And so then taking the square root, what do I get? It's not a trick question. Plus or minus square root of 5. There you go. Okay, again, or you can write it as r is equal to the square root of 5 or r is equal to negative square root of 5. Okay, either of those acceptable.
It just, it seemed like a trick question.
If this had been something that could have been broken down, okay, then we'd want to break it down, but 5 is prime, so you can't do that. Alright, let's just do one more of these. 32. Get about as hard as they get here. 7 times x minus 4 squared minus 18 is equal to 10. So what do I need to do first?
Square everything first? In the parentheses, no?
Don't do that.
Just distribute first?
Don't do that either. I want to ultimately get x by itself.
Add 18 to both sides.
So I want to leave this how it is.
Add 18 to both sides.
Add 18 to both sides.
Oh, and then, okay.
Now what?
Divide 7 by both sides. And then it's by itself, so
multiply 7 times x.
it's by itself now, right? So
Nope, I mean I truly want x by itself. Like x should be the only thing left over there. But this is where this problem's going to get a little different than what we've done than the other two problems, okay? I have to undo this square first, so I need to take the square root of both sides. Okay, so then I'm left with, on the left, x minus 4 is equal to plus or minus, okay, the square root of 4 is 2. But I'm not done now. X still isn't by itself. So this one has to be set up as two separate problems. Okay? So I'm going to have x minus 4 is equal to positive 2, or x minus 4 is equal to negative 2. Okay, those are the two possible options that I have. So, add 4, we get x is equal to 6, or adding 4 to the other one, x is equal to 2. Okay, so in this one it has to be written separate. One answer isn't positive and one is negative, but I have two answers. Okay, taking a square root, you always have two answers. Okay, if it's just something equal to the square root, it's just plus or minus whatever's in the square root. This one, because there was stuff inside of what was the square root was being taken, or what was, since there was stuff inside of what was being squared, I had to wait until the end to move that part over. Okay. Any questions? Good. Okay. So then your problems to go with this section: 3, 7, 9, 11, 17, 23, 27, and 31. And like I said, you have a little less than 15 minutes right now, and then tomorrow you'll have time to work on this section as well. And then make sure for Friday, if you haven't already watched the 4.6 video, that you watch that.